The earliest dinosaurs evolved in the mid-Triassic period. By the end of the Triassic, these first dinosaurs, which were small, bipedal, and unspecialized, had evolved to diverse groups, including the early Ornithiscians. Now, the early Ornithiscians were small, bipedal, and unspecialized, not that unlike the earliest dinosaurs. They did have a few traits which define them as ornithischians, such as a pubic bone, which was retroverted, which was oriented posteriorly, and a few other features, such as ossified tendons in the back, which would stiffen their back, a predentary bone, a bone over the eye, and other features. These ornithischians adapted to eating plants, while other groups, the theropods, were adapting to a life of carnivory. And so many of the herbivores then were ornithischians, and the group that I would like to discuss today, the ornithopods. Now, when I discuss this in class, one of the problems we need to deal with first is very few people have an ornithopod as their favorite dinosaur. When children are asked who their favorite dinosaur is, very often it's a theropod like T-Rex, or a horned dinosaur like Triceratops, or a sauropod like, Diplodocus or Brachiosaurus. But these ornithopods very rarely make, the top cut. And so students may not approach this with the interest, which they deserve. So just a couple of thoughts on the ornithopods. One is, let's say you do like Tyrannosaurus rex. Well, it was a meat eater, and ornithopods were major herbivores. By the end of the Cretaceous period, they were one of the two groups which was really exploding in terms of number of new species. So obviously the theropods needed to eat something, and ornithopods such as hadrosaurs at many fossil sites compose the major dinosaurs found. And so there would not have been theropods like T-Rex if there weren't ornithopods on which they were feeding. Ornithopods include many of the earliest dinosaurs. So Iguanodon was one of the dinosaurs for which the group dinosaurs were named, when it was realized, wow, there are these giant reptiles, enough that perhaps they form a group. For a while, Iguanodon was the best understood dinosaur. It was an ornithopod. Here is a fossil of a hadrosaur, which was found in New Jersey. As such, it was the first American dinosaur, the first dinosaur to be put on a display for people to observe, even the state dinosaur of New Jersey. And then just, so many other thoughts about these ornithopods. There are so many fossils of them. That there are examples of skin impressions. And so if, your question was, what kind of skin did dinosaurs have? Because there are so many ornithopod fossils, ornithopods could help give information that's not only true of them, but of other dinosaurs as well. Because some of them preserve gut content, say fibrous plant material. There is information there of interest. Because we have so many fossils, it's recognized that there were gender differences, say in the crests of the hadrosaurs. And as we discuss dinosaurs in general, and their possibility of social living and courtship, etc., then that is important. There are fossil sites not only of dinosaur nests, but evidence that both dinosaurs could travel in groups and nest together, that dinosaurs could return to the same nesting grounds year after year, because you can find, egg sites with, then sediment and then more egg sites over it, suggesting that the dinosaurs were returning there. And then even suggestions of care for the young. So if young of different ages are found near the nest, that suggests that they remained there for a while and were cared for. Otherwise, they wouldn't have stayed in that vicinity. And so once again, even if Ornithopods are not your favorite dinosaur. Nevertheless, they were certainly critical in dinosaur food chains, especially towards the end. If we want to have a discussion, did dinosaurs become extinct with a bang or with a whimper? I mean, were they all dying out anyway? And at the end, the last couple lineages simply died. Well, hadrosaurs and horned dinosaurs, they were diversifying like mad. That was where they had their richest diversity. And so, questions about how did the dinosaurs die, ornithopods are critical in that. And then other things, once again, gut contents, skin coverings, social living, nesting, care for the young, because there are so many ornithopod because there are so many ornithopod fossils that they are valuable to help study all dinosaurs. Now, if we were to start with the earliest dinosaurs like Eoraptor, it would not take much change to convert the skull of, say, Eoraptor into the skull of a basal ornithischian with its predentary bone and this bone over the eye. And this would not take much change to convert then into the early ornithopods. The early ornithopods were small bipedal, and while later groups would have great adaptations for chewing plant material, that was not true of the earliest ornithopods. The predentary bone resulted in the loss of teeth in the lower jaw at the very tip of the snout. And then in later ones, the teeth in the upper jaw would then also be lost. And so the ornithopods, after the earliest one, had this beak would cross, and then rather unspecialized. They don't necessarily touch each other, the mouth is closed. They don't allow for a chewing. There is one row in use and then another backup row that will replace the first as those teeth are worn out. This will change over time. And so there are these early ornithischians, which were small forms. Once again, there are lots of different herbivores today included. So while there are large herbivores like elephants, giraffes, and cows, certainly many smaller animals, rodents, for example, are making use of plant material. So some of the ornithopods remain small bipedal forms. Some of them ended up going to southern continents. So once again, something that we could learn from the ornithopods is one, such as known as Lialnosaura, went to Antarctica and seemed to live there all year round. Its eyes were rather large, which would make sense given that continents near the poles had periods of extended darkness. While Antarctica was not frozen the way it is today, I mean, it was certainly approaching the South Pole at this time. It was certainly cold. And so when we get into discussions about were dinosaurs warm-blooded or cold-blooded? Once again, the fact that dinosaurs could be found near the poles as such as small ornithopods, that could be discussions. So, from the early ones, the diversification of their lineage, the Mesozoic era, sort of not all appear together, nor do they all die together. There are ornithopons which are only in the Jurassic period, only in the Cretaceous. They're found living in the Cretaceous after the things come later. From small ornithopods, which and the Hadrosaurs of the Cretaceous was the most diverse group of, and at the end of the Cretaceous, one of those systems of dinosaurs. So Hadrosaurs, which included dinosaurs, present dinosaurs, they are known throughout the Mesozoic era, only at the end, and they'd be, the final branch in the family. Now, as this lineage progressed, perhaps the most significant perhaps an increase is the ability to chew plant material. It may recall that the prosauropods were successful dinosaurs at eating plants, but they become extinct in a short period. Why? One possible reason for that is competition. And new groups of dinosaurs had evolved which were better at eating plants than they were. And by the end, ornithopods would be great at eating plants because of their ability to chew plant material. Now, when I say, chewing food, we take that for granted. Doesn't everything chew its food? The answer is no. Most things don't. Here's an example of how a complex trait, like the ability to chew food, could then evolve in stages. So if we were to ask how many teeth were in a row in the cheeks in these primitive ornithopods, 10 maybe as a minimum in some species, 16 in others, not a lot. How many separate rows of teeth were there? 2, one that was being used and then a backup row. So that's the starting point of teeth in this group. But then if one were to say, all right, what happens then over time? One see that this group loses teeth in front of the jaw. So it becomes a toothless beak, probably covered with a horny keratin beak. But you get more advanced groups like the Iguanodons, which I'll mention. Then you could have 20 to 25 teeth in a row, and now 3 rows of teeth. By the time we get into 3 teeth in a row and primitive ones, 50 teeth in a row, so that would be 50 here, 50 here. Then you could have now 3, 4, 5 rows of teeth. All right, so some of the hadrosaurs, they can approach 2,000 teeth in their the mouths in various stages at a time. And so what we have is lots and lots of teeth. Now, not only are there lots and lots of teeth, but they contact each other. They fuse together and they form a platform for chewing, what is known as a dental battery. All right, and so a lot of animals like crocodiles, their teeth don't touch. They just open and close their mouths. Whereas here, these teeth were all fused together to form a grinding platform, making them very efficient at not only eating plant material, but eating woody plant material. And so there were a number of plants in the area that something like a prosauropod would not have been able to eat. It just wasn't that adept at chewing. But because these animals could have just ground the plant material along this dental battery, that would have made them very efficient at chewing. And so therefore their success is probably in part large due to their ability to get nutrition efficiently from plant material, while other organisms might have been more challenged by that. Okay. Now, the greatest chewing ability is observed in the hadrosaurs. This was the terminal group, but the hadrosaurs evolved in stages. So from the small bipedal forms, then there were forms such as camptosaurs, which come later, which were larger, that could have been bipedal, all right, but that probably were so big that they could go down on all fours at least part of the time. Descending from camptosaurs was Iguanodon, one of the best known dinosaurs of at the end of the 1800s. There were multiple specimens known. So Iguanodons could be very large, the largest ornithopods to date. And Iguanodons spread all throughout the world. There were Iguanodons in North America, in Europe. They were even in Australia and Antarctica, perhaps migrating to Antarctica during the warmer seasons. And then it was from groups like Iguanodon that then the hadrosaurs would evolve. As this group became more adept at eating plant material, they could get bigger. All right, and so, for example, the Disney movie Dinosaur, it was a cartoon with a Tenontosaur as the lead, Aladar. That was an ornithopod, which had achieved a much greater size than the earlier ones. And notice that by now it's quadrupedal, that as they got bigger, while walking walking on their hind legs would have been possible. Standing on their hind legs to reach higher branches and pull branches down to eat would have been possible. Nevertheless, just the body proportions probably means that a quadrupedal stance would be more likely. Okay. So from then camptosaurs, then animals enlarge and then produce the groups of Iguanodons. Now, notice that these hatch marks along the spine mean that there are these ossified tendons in the tail. So this would hold the tail more rigidly as a counter balance. Iguanodons spread all throughout the world, and so therefore were quite diverse, and different species then lived in different parts of the world. One of the most interesting things perhaps about Iguanodon is the adaptations of the hand, all right, because some of the fingers look to be dexterous. And so Iguanodon could probably grab branches and bring them down and use them to eat. So it had dexterous hands it could use to eat. But this big animal then had digits which were adapted, probably bearing hooves in life, to bear the body's weight. And then also then the thumb had fused bones, which then could obviously arguably then be used as a weapon. So in a defensive means, Iguanodon had no armor or spikes, etc. But this one bony thumb could arguably inflict harm. And so therefore, when one looks at its hand, it seems that it's adapted for multiple purposes. As we will see in some of the hadrosaurs, the nasal region of some species became more elaborate. As always, we don't know why. I mean, did this have something to do with exchanging heat, for example? It's possible. One of the things that we would argue, and I'll get back to this presently, is because there were so many different hadrosaur species, they were quite diverse and quite successful, then just like, say, modern ducks have a problem in spring when it's mating time, because they have to know which other ducks on the lake are part of their groups and potential mating partners. And so coloration, is very important in them sorting their groups out. Other birds use song. Well, this animal, if it were then to make a call, a noise, because of the shape of its nasal area, it would arguably then sound very different and perhaps look very different from other species. And so if animals herded together, if they migrated together in a group, if in mating season they were announcing territories or distinguishing between species, then something like this could be useful. Now, that is certainly reasonable, knowing what we do about modern animals. But that being said, this is a guess, an educated guess, and then I think quite likely to be correct. But when all one has are the bones, it's difficult to test things like this. Some of the iguanodons lengthened the spines of their vertebrae to produce low sails or slightly more significant sails. And just as we consider with other dinosaurs, perhaps this had a role in thermoregulation, helping an animal warm up when it was cool faster, or if a wind was blowing, cool down when it was warm faster. Perhaps this was an adaptation for thermoregulation. By the Cretaceous period, another group of hadrosaurs or of ornithopods had evolved, which was then quite successful. They varied in size, but as you can see here and here, notice that that's the second story of this museum, this one in Philadelphia, that they could have a very significant size. So not the size of sauropods, but very large herbivores still. Once again, notice here in New York City, here's a Cretasaurus on display. Look at that dental battery. See, there are just so many teeth all in a row, and they are all fused together so that this animal had a grinding platform for its diet. Now, it probably did not chew side to side the way we do. It probably chewed going back to front, which is a little different from how we chew. But this dental battery was significant. And as I mentioned in the last video, it evolved in stages. Also notice, this very large nasal region with its depression here. Now, just a couple of other comments on these hadrosaurs. As I'd mentioned, there were ossified tendons, which would have meant the back stayed more rigid. One of the early ideas for hadrosaurs was that perhaps their crest were kind of like scuba tanks, that they could bring down tanks and swim underwater, but their backs were too rigid to have allowed that. One of the things that helps me chew my food is I have a cheek. All right, I can put food here. My mouth, my teeth are inset. There's a space between this cheek stuff and my tooth row. I have an inset tooth row. Well, if you look at these duck-billed dinosaurs, or these hadrosaurs, you can see the same. All right, their tooth row was inset. So they had cheeks. I have cheeks to help me hold plant material so I can move it around in my mouth. And then so did they. Now, once again, this, if you were to say cut off the snout of a hadrosaur, you would see row upon row upon row of teeth, and then more in the process of forming. And so that they would continually change teeth throughout their life. But not only do they have so many teeth in a row, but then they have multiple rows exposed, all right, and then rows back, replacement rows behind that as well. All right, and so the hadrosaurs then are very successful, and so much so that the hadrosaurs are split into at least 2 subfamilies. In one subfamily, the head tends to be flatter. And just if you're not familiar, in biology, if you ever see a group ending in NAE, that's a subfamily, whereas a family ends in DAE. So Hadrosauridae would be a family that could then have 2 subfamilies, Hadrosaurinae and Lamby Asourian. And so this is the branching of a family tree. And among the hadrosaurs, then there were specific groups. So the Hadrosaurinae, they tended to have flatter, uncrested heads, while the Lambeosaurs had crested heads. And we could argue, so, biologists are continually proposing, is there a better classification system? This one here with a solid crest, Saurolophus, perhaps that belongs in its own group, okay? And so hadrosaurs are not only in group, but then we could subdivide them into subgroups. Now, once again, they could be quite large, and they would be capable of both bipedal and quadrupedal locomotion. So in this video here, I simply, tried to show that over, tens of millions of years, it would not be significant change that you would need in the skulls. All right, so the skulls were comparable, but in some lineages, perhaps, the nasal region would enlarge, or there would develop a crest. But the skull changes would not have been excessive, especially given tens of millions of years. So once again, these animals, which varied in size, some were considerably large, could both walk quadrupedally and bipedally. And so perhaps a bipedal locomotion might have, perhaps, I'm just imagining, served perhaps to in sprinting away from a predator, or standing on one's hind legs to reach upper branches and access more vegetation, while more quadrupedal locomotion, perhaps this was more energy efficient and allowed for migration of longer distances, etc. So here you see a Hadrosaurinae hadrosaur. Notice its flat head. Also notice that although it doesn't have a sail, nevertheless it does have some lengthened vertebrae. Now this would allow for more muscle attachment, which would, for muscles which were supporting the tail, etc. But just pointing out that one could see a difference between, say, a full sail, and a smaller sail, since sails were simply made of lengthened neural processes of vertebrae that we see, vertebrae with some lengthening, some vertebrae with more lengthening as well. The other subfamily of hadrosaurs was the Lamby Asourian subfamily. These would also have been capable of both bipedal and quadrupedal locomotion, and they possessed crests. And because we see such variation in the crests, then the question is why? Well, the crests were hollow, all right, so they certainly wouldn't have allowed for ramming. They weren't defensive in any way. And because they varied from species to species, then the idea, especially given that they were hollow, is that they would have affected vocalizations. Now, I'm going to go back to some of my images in the PowerPoint in just a second. But in my class, one of the things that I do is, I just remind them that a lot of birds are communicating as far as with other members of their group, and especially around mating time, with vocalizations. And you can tell, say, one warbler from another because they sound different. And if these hadrosaurs then had different size crests or different, nasal regions, then each one would have had a specific sound, a different type of vocalization that perhaps would have helped in gregarious behavior. So in my classes, I split a class into 4, and I give each quarter of the class a one of these 4 hadrosaurs, and as Beethoven's Ode to Joy is playing in the background, they hum along with it, just to kind of serve as a memory trigger for that these would make different sounds and help groups come together. One of the things which has been observed is that in certain populations, not only are there differences in crest from species to species, so that one could say distinguish between Parasaurolophus and Ornithosaurus and Lamby Asourian, et cetera, and Hypacrosaurus. So not only could this help a species, perhaps given that the hollow form here could affect sound production, that there could then also be differences within the species which might be associated with gender differences. And so Parasaurolophus crest, not all Parasaurolophus had the same crest. There seemed to be a difference in shape, which then onset when animals were getting big, arguably reproductively mature. And so was this, then did vocalization have a role in courtship or mating? And then it would make sense that dinosaurs of the age that would then be start courtship and mating would then manifest gender differences in their crests. Now, we don't have to just pick one possible use of these crests. So for example, hadrosaurs lacked armor and spikes and things like that. And so perhaps one of the things that they could use to defend against predators is to be able to detect them from a long way off, and then just to run and escape them. And so a very large nasal cavity might also then have expanded their ability to detect predators from afar. Once again, no way of testing that, but we wouldn't have to pick, courtship or increased olfaction. The two could go together. As I mentioned, hadrosaurs seem to have traveled in groups. There are certainly trackways with lots of tracks going in the same direction, suggesting that a group was traveling. There are nesting sites where lots of separate nests are in the same area, suggesting that the group nested together and that perhaps even migrated to the same nesting site year after year, and perhaps even then offered parental care with, some analysis has suggested an abundance of seeds near nest areas, as, perhaps suggesting that parents were regurgitating, food for their young the way many birds do, that fossils of different aged infants around the nest suggest that maybe they stayed there for a bit and could be cared for. Okay. So hadrosaurs were quite diverse at the end of the Cretaceous period. So dinosaurs were not dwindling and slowly being replaced by mammals at the end of the Cretaceous. Dinosaurs were doing quite well. And the hadrosaurs and ceratopsians, the horned dinosaurs particularly, were continuing to diversify when suddenly they become extinct. So as we discuss the extinction of dinosaurs, this would be one of the piece of evidence to consider, that it seems to have been a sudden event that ended a group which was otherwise doing quite well. And so once again, while ornithopods may not be the first dinosaur group that many people speak of, their role in food chains as herbivores, certainly meant that they were, very important to many groups of dinosaurs. And a lot of things that we know about dinosaurs in general come from ornithopods because we have so many good fossils of them.